So double angle identities, we're going to find the exact value for sine and cosine using these identities. So the identities we have, there's only one for sine. So sine 2 theta is 2 sine theta multiplied by cosine theta. Then we have 3 for cosine. So we have cosine 2 theta is cosine squared theta minus sine squared theta. Then we have cosine 2 theta is 2 cosine squared minus 1. And then we have the cosine 2 of theta is 1 minus 2 sine squared theta. And tangent, there's only one, is 2 theta is equal to 2 tan theta divided by 1 minus tan squared theta. So these are the double angle identities. So the example, find the exact value of sine 2 theta when equals 2/3 and theta is between 0 and 90. So we need to use the identity. So we're going to use sine 2 theta is equal to 2 sine theta multiplied by cosine theta. And we're going to use this to find the value of cosine. So cosine squared theta is equal to 1 minus sine squared theta. So we're going to substitute in the values. So cosine squared theta is 1 minus, and we're given that we have 2/3 squared. So cos 2 is equal to 5/9. And if we take the square root, we will have plus or minus 5 root 5/9, which will simplify 2 plus or minus 5 root 5/3. Now if we look at our cast, and we are looking for an angle which is between 0 and 90, we know that everything is positive in quadrant 1. So cosine of theta will be positive. So we're going to take the positive value. So now we need to find sine of 2 theta. So we know we're going to use 2 theta is equal to 2 sine theta and cos of theta. So we're going to substitute in the values. So we have 2, let's make that a bit smaller. So 2 multiplied, sine is 2/3 and cosine is 5/3. And if we multiply these, we will have 4 root 5/9. And that is our final answer. So guided practice, find the exact value of sine 2 theta if cosine of theta is minus 1/3 and 90, or between 90 and 180. So we can use cosine squared theta plus sine squared theta is equal to 1, which, so if we rearrange, this is sine theta is 1 minus cosine squared theta, and we need to find sine. So if we substitute in the values that we know for cosine, and cosine is -1/3 and is squared. So sine squared theta is 1 minus 1/9. So sine squared theta is 8/9. So what we need to do is take the square root of both sides. So we'll have sine theta is plus or minus 8/9, which will simplify to plus or minus 2√2/3. Now if we look at our cast diagram, and we are looking for between 90 and 180, so we're looking in quadrant 2, and in quadrant 2 sine is positive. So we're looking at having the positive 2√2/3. So we need to find sine. So let's separate this. So we need to find sine 2 theta. So this is going to be 2 sine theta cosine theta. So this is 2 multiplied by 2√2/3 multiplied by -1/3. And this will be minus 4√2/9. So example 2, we're going to find the exact value of each expression. So find the exact value of each expression. And we're given this if sine theta is 2/3 and theta is between 0 and 90 degrees. So we're asked to find cosine of 2 theta. So to do this, we're going to look at the formula that we know, double angle identity. So 2 theta, we're going to use the 1 minus sine squared theta because we know sine. And we can substitute in the values. So this should be minus 2 sine theta. So 1 minus 2, and we know that sine is 2/3, and we need to square. So we're going to have 1 minus, if we multiply this out, 2 squared is 4, and times 2, that's 8, so that's 8/9. And this will be, so cosine of 2 theta is going to be 1/9. Now, the next thing we need to do is find tan theta. Now, to find tan theta, we know that tan theta is sine theta over cosine theta. So we can substitute in the values that we know to work. So we can replace, find tan first, and then we can work out the formula. So the first thing we're going to do is substitute in the value. So we're going to find tan. So we know that sine theta, we said is 2/3. And this is divided by 1 divided by 9. Actually, it's not 1 divided by 9 because that is 2 theta. We need the previous answer that we worked out, which was if we go back, we had cosine is root 5 over 3. So we're going to use root 5 over 3. And we need to multiply. So we can multiply both by 3, which will simplify. And this leaves us with 2 root 5. So if I rationalize the denominator, this will leave us with 2 root 5 over root 25, which simplifies to just 5. So tan theta is 2 root 5 over 5. Now we need to use the angle identity for tan. So tan 2 theta, the angle identity is 2 tan theta divided by 1 minus tan squared theta. So what we're going to do is substitute in the value that we've just worked out for tan. So we're going to have 2, and we know that tan theta, so this is tan theta here. Let's highlight that so we know. So we're going to use this value. So tan theta is 2 root 5 over 5. And this is divided by 1 minus 2 root 5 over 5 squared. So if we multiply out, we're going to keep this the same. So 2 root 5 over 5, and we multiply out the bottom. So 5 squared is 25. And so we're going to put this as, this is 20 over 25. And 1, a whole 1, would be 25 over 25. So if we simplify, we will have 2 times 2 is 4, so 4 root 5 over 5. And 25 minus 20 is going to be 5. 5 over 25. So that is simplifies to 1 over 5. So if we multiply both by 5s, these will simplify. And our answer is going to be 4 root 5. So tan 2 theta will be 4